And welcome back. Now today we're going to be talking about LCDs, specifically I2C communications bus, which is far simpler than what you might think. It's only 2 wires plus 2 for power, and I'll explain how you can identify the hex code of each of your individual units. So for example, this thing here that we're looking at, this is communicated to via I2C, and it has a unique hexadecimal address, as does this little one at the back here. So this is another LCD, but it's far smaller. But it has a unique address, just like your house, so that the data knows where it's going, or rather, the unit knows which data to accept. But we'll talk about that in a second. Let's have a look where I got these from. Here they are in Banggood. In fact, I'm not sure whether I did buy them from Banggood. Might have been somewhere on eBay, but it could have been here. If you buy them direct from the EU warehouse, or indeed the US warehouse, it takes about a week, and the price is here £3.20 in UK money. If you buy them from China though, it's £2.62. You'll have a 4-week wait, possibly a bit longer, possibly a bit less. Pays your money, takes your choice. But that's pretty good in my view. Now that's for the 16:2 display. So if you look at the one I have here on my desk, that's this little one that I haven't connected up yet, but will be in a minute. So that's 16 characters across and 2 lines deep. That's what that means, 1602. Now the bigger one is over here. Let's have a look. There we are. So this is the 2004, which means 20 characters by 4 lines deep, as it says in fact, a little bit further on. And I can only get these from China. £4.74, which is still pretty good going. Now this is the alternative colour though. Does that make it any bigger? Yes. So this is the yellow and, well, I'm guessing that's black. Yellow and black. Personally I prefer the blue. I think it's just more, I don't know, a bit more technical. Looks at. It doesn't show it here of course. I'll have to look at my desk for that. So the actual, how it looks. See, well, that's pretty nice, isn't it? In fact, the blue looks particularly washed out on camera. In real life, that's a nice deep blue. I don't know why it should be like that, but there we are, that's technology for you. Okay, so back to the screen. Now, the only thing you may want to look at is the data sheet for the HD 44780. That's this bit here. Now, this is a 60-page data sheet. You don't need to look at anything on there apart from this one page, page 17, because it gives you all the characters that you can possibly print without doing any kind of customization. So your standard hello world type of thing would automatically use these characters without you doing anything. I'll show you that in just a sec. And you may want to use some of the more odder characters like splodges like this, and we'll go through that as well. So on to the code. So here's the code that we're just going to use for our first bit of the demo, the simple bit. We need the I2C wire, because that's how we're going to talk to it. Here's the Liquid Crystal I2C recommended library we use, which is in fact here. Go to GitHub, or just do a Google search, find this FDE Brabander Arduino Liquid Crystal I2C library. Download that by doing unzip the underlying library, which will contain these two and the examples and everything else. In fact, it will contain all this in the library, which you may have to rename. Oh, it tells you here, look, how to install it and rename it, and just put it in your libraries folder. So that's good to go, just like any other library, no difference. Here's the hexadecimal address of that little unit, actually, not the big one. They're all different, and your supplier will tell you. But what I'll do, underneath, I'll put a bit of code that allows you to scan the I2C bus and tell you all the devices it can find. And of course, if you've only got one plugged in, it'll tell you what the address is that it's found it on. Help me out no end. Here we instantiate the Liquid Crystal device. Now here we define a character. There's 2 ways of defining a character. Either like this, which looks very pictorial. If imagine this is in fact that little square blob on screen. So let me just bring that up again. So on here, if you can see, let me turn the contrast up a bit, and then you'll be able to see how they're made. Now look, you see I've turned up the contrast so you can see the individual dots that make up each of these characters, and it's 5 dots wide by 8 dots deep. Okay, I think that should be easy enough to see on there. And what we're defining is each of those 5 by 8 characters. Right, so on screen, what we're saying is, here's my 5 characters going across, B means binary, by the way, and 8 deep. So what we're saying here is, look, there's 3 lines completely filled, no spaces, and then we have 5 lines that are empty. So you've got 3 and 5. And in fact, if we just nip back to the screen here, we have here a perfect example. This number 2, for example, has got 3 lines filled in here as part of its character with all the rest empty, and that's part of the 2 digit, which we can just about make up. I've turned up the contrast too much now, I'll turn it down again in a sec. So back to the screen. Now, so this is one way of defining it, and it's quite pictorial really, because you can see the 3 lines and the empty lines underneath. An alternative way is like this, where we actually take each value and plug it in one by one. So the first value is the first line, the second one's the second line, and so forth. These aren't the same character, by the way. This is just for demo purposes. So this test character has been defined with 8 characters, or 8 individual segments going down 5 digits wide. And you'll see what that is in a minute, that test character. So we're setting up the serial port just for debugging. It's always useful to have some debugging in your code, so you can see something on the serial port, which of course you get to by clicking that to get the serial port up. Not that we need it just now. So what we're then saying is, begin the LCD, which is initializing it, turn the backlight on, which may be by default anyway. A small delay, so let the thing initialize. If you do it too quickly, it might not take the first command. Then we're creating our first custom character. What we say is create char, put it in position 0, and you've only got 8 of them, 0 through 7, and test char is the array that we've defined here, look. See that? That's our test character, and these are the little bits of the character that make it all up. Then we are sending the LCD cursor home, printing a bit of text as you would normally, just like serial.print, and then printing our custom character. So let's see what that looks like on a 16 by 2, not this big one, a 16 by 2 one. So this, I'm going to unplug this, I'm going to plug this in, upload that code we just saw, and see what it looks like. Right, so the code's been uploaded, and this is what the result is. It says temp 24, and then we have our little custom character, which is this one here, which is representing, of course, the degrees centigrade. But what it is, you can see if I bring it really close to the camera, you can see it's 4 little dots, followed by a tiny letter C. And that's defined in that custom character. Now that's fine for individual characters, you can have 8 of those. So if you've got, I don't know, a specific use for some characters like that one, that's how you would do it. But what we're actually going to do, we want to have some big characters on our screen. So by defining 8 custom characters that make up a digit 0 through 9, we can display stuff like you saw in the introduction. So I'm going to swap these back over, bring up some new code, and we'll see how that hangs together. So here we are back then with new code, big display. So let's upload that code to it, which is this one here. So uploading now, and as you can see from here, it doesn't take very much. It's only 5K, all this, including the library and everything else. Only 604 bytes of your SRAM as well. So that's a fairly lightweight library, unlike the last one we looked at, which took about half the available space. So that's up and loaded. So let's see what that looks like on screen. So here it is, and it says, hello Arduino fans. I've got to turn down the contrast now. Having shown you the blocks and how they made up, it makes it difficult with the camera to pick out the actual lines. So let's have a look. It's a little bit different to camera than in real life, I notice. Well, that looks pretty good, although you can still see the blocks. Now in real life I'd probably put it something like that. for the camera. Do we need any more? Yeah, a little bit more like that. Just perfect. Right. Now, as part of the demo, of course, I've got 3 phases of this, so I've just got to press a button on the breadboard here, especially set up so I can do it in 3 phases. So that's standard printing to the LCD, just lcd.print and then whatever you want as a string. Remember that you've only got either 16 or 20 characters. But what we want to do is print out some big digits like this. So what we've made up here is on this screen, what we've got are blobs like this that we've carefully put together. Well, I have, and it took me a whole lunch hour plus an evening to define all these, to make up the characters. Now, as you can see, I've only got 8, so I've got these 4 here. Look, this one here, for example, it's like a full blob with just the corner missing. I've called them chamfered. So you've got left top chamfer, bottom left chamfer, right. Then you've got this dual one where you've got a line at the top and one in the middle. And what else? We've got this blob here, which we've already looked at, this big blob. And I think that's about it, actually. Everything else is made up from those. Anyway, there's 8, plus you get 2 freebies. So if we look at the code, everything else at the front is the same, apart from the address. Look, the address has changed now to 0hex27, because this is a larger unit, it has a different hexadecimal address. I think you can change, yes, you can change that one as well by soldering some of the pins underneath. Let me show you that very quickly. If you look underneath these units, and when you buy them, make sure they have these I2C boards either already attached or come with it. So you push them through and then solder them up. Don't get them without these I2C boards, because otherwise you'll have to buy a board separately, and that's $1 all by itself. Now, on the back of here, you can see here, look, it says A0, A1, A2. By shorting out some of these solder blobs, and without looking at the spec sheet, I'm not sure which ones you do, that can change the hexadecimal address of this unit. So if you wanted, for example, 2 of these boards together, and you might have a very big display, who knows, something, I don't know what you might have, but anyway, you might want 2, and if you did, you then have to solder together some of these pins here, and it changes the address, but the spec sheet will tell you that. And the only other thing going to this I2C thing at the back, you've got the ground and power, of course, but it's a 2-wire protocol, SDA, SCL, and that corresponds exactly to the same pins on the Arduino. The top, there we are, look, SCL, SDA, it's just 1-to-1. Just match them up and you're good to go. So, there we are, that's that. Let's get back to the code and see what difference we've made and how we've defined those characters. Now, I showed you in the last bit of code how you could define your characters either as a string like this or as a binary format like this, which is a bit more visually appealing in the sense that you can see at a glance that that line is complete, that line is complete, and all the ones in between have nothing in them. But once you get used to this for a while, you know that all the bits, 5 bits together, make up 31, because the first column here is 1, the second column is 2, the next one's 4, the next one's 8, and the very first one there is 16. That's how binary works. There is a video on this channel that describes binary. Can't remember which video it is now, but if you've been following the course you'll see that. So rather than doing them visually like this, you can just do it like this. These two, by the way, I've commented line 27 out, that is exactly the equivalent of that. And it's entirely up to you how you do it. It doesn't take any more space one way or the other. Just depends how you like to do it. Now, these are my big numbers. So what I've said is, having defined all these custom characters, the blobs, the chamfers, the top and bottom lines, in what sequence do I have to put them together to make a character? So if we look at the 0, for example, and just quickly nip back to the screen here, my 0, if you look at it, it uses the chamfer characters, top and bottom. Oh. So we've got chamfer characters there, there, there and there, and then top big blob, oh, that's a tongue twister, top big blob, and bottom big blob. Okay, so they're the 1, 2, 3, 4, that uses 6 custom characters just for that one letter. But some others use significantly less. We'll just come on to those in a minute. You get a couple of freebies thrown in. So here's my 0. It's made up of custom character as defined up here. 7, which is this one here. It says 7 on it. Followed by a 0, which is this one up here. Followed by a 5 and a 4 and a 1 and a 6. All these ones here. They've all got the numbers at the end just so you can see which one's which. Now, some characters, like the 1, I'm using 254 and 255. Well, we haven't defined those. The 255 and the 254, as in the 1, if I bring this close here, it's this solid block. This solid block where all the bits are set. That is a 255 and you get that for free. And this top right hand corner here where there's nothing shown, that's a 254, so you don't have to define those, which makes it useful. So you really get 8 characters plus 2, sort of. You'll always wish there's more room, believe me. Now in the setup code is exactly the same as it was last time. A little bit of mucking about for me for my demo, ignore that, I'll take that out before this gets posted. Here I'm printing the big numbers, and if we go down to the print big num method, what we're doing here is saying where do you want it to start, here rather, and what's the number you want to do. Well, the number is an array, so number 0 is array position 0, and number 1 is array position 1, and so on. Just happens to work out like that way, or at least that's the way I made it work out. Now remember that these numbers are split over 2 lines, and when we print them, remember that we're printing, so let's take the number 2 for example, we're printing 3 characters, 1, 2, 3, then dropping a line and printing the remaining 3. So whatever column we start with, we print 3, go back to the original column, drop a line and print the next 3. That's how the big num method works. And in fact it's so simple that I'm not going to go through it line by line because it's pretty well documented. It shows you that we extract the data, we print the first 3, reset the cursor and print the second 3 blocks of each character. And that's it, that's what we do. There's nothing in the loop in this one because there's nothing to do really. I'm doing everything up here. So this is mostly demo code. I'll leave the demo code in though so you can see what's happening. You'll just have to figure out a way of moving it forward in the demo. So because it's pausing on each part of the screen. So it's pausing now. I have to then press this button which basically just does a short of pin 7 to ground. It's defined as a pull-up input. So if I press it, you'll see on camera, if I press it once again, whoops, not that one, that's the reset, that one over there. So therefore it just moves to the next bit of the demo with that number constantly changing. There's no way to get back now, so I'm going to have to reset it because there's something else I want to show you. Yes, hello Arduino fans. Right, now you notice on this display here that we do have this comma sort of just put in any old position here really. It's not really part of the 7, is it? That blob is really all part of the 7. So I printed this comma afterwards over the top as a standard character, and in the code it looks like, where are we? Here. So we're setting the cursor position, so it's row 3, remember it's 0 base, so 0, 1, 2, 3, which is the bottom line, and character position 11, counting from 0, 0, 1, 2, that's the 12th along. I'm just saying put the comma in there, and it's a standard comma. If you want a bigger character, you could print, oh I don't know, a splodge. In fact I must have it up, there we are, look. This commented line out shows that you can print 46, which is quite a large full stop or period, and 161 is a larger empty one. In fact we can look at these on here. That one here is 161, which you can work out because the upper 4 bits, as it says here, is 1010 and the lower 4 bits is 0001. Put those together, put it into Google if you can't work it out, and it comes up to 161. So that's just another character you can use for free because it's built in. And that basically is that. Whilst there are 3 steps here, which I'm using as the demo code, all parts of it are self-explanatory. I'll put lots of comments in out of the 169 lines, including this blank line, I would say at least half are comments. And of course some of them spread the code, because when you do a binary character like this, it does move it down quite a bit. So there we are. That's your big fonts, well, big digits anyway. And let's see what the temperature is. Ah, there it is, 24.7 and dropping. Big fonts, the Arduino. Pretty easy to do, and if you don't like the fonts, you can of course change them. So have fun with that, and if you've got any questions, well, don't knock the camera over, just put the comments in the bit below this video, and I'll answer them if I can. Okay, great, thanks for watching. I hope you're finding these videos useful and interesting. Remember, you can leave comments down below, and also click that little button that says subscribe. Okay, thanks for watching, and see you in the next video.